So the question says, use the graph of y equals the square root of x to graph y minus 2 equals negative square root of 3x plus 3. So first thing that we have done so far in all of our equations is move that 2 over to the other side of the equation. And then if we go from left to right, first thing we run into is a negative. Vertical or horizontal? Vertical. It's outside of the function. So a vertical reflection over the x-axis. Next, we run into the 3. Vertical or horizontal? That'll be horizontal. It's inside the square root. It's going to be a horizontal stretch or compression? It'll be a compression because you will multiply x by a third. So if we were to describe that, we'd say a horizontal compression by a factor of 1/3. 3, horizontal or vertical? Horizontal. And what are we going to do? Move 3 to the left. That's what our gut says, right? But we've already forgotten that special note that we were supposed to put a reminder at 10 p.m. in our phones last night. Do you see that this isn't in the factored form? So when we have a horizontal translation and a horizontal stretch, reflection, or compression, we need to first factor out that 3, which would leave us with x plus 1. That 1 will be a horizontal translation 1 to the left. So now that I've written it in proper form, I'm actually going to label these. This is going to be a vertical reflection. You're going to multiply y by negative 1. Here we have a horizontal compression. You're going to multiply x by 1/3. Here's our horizontal translation, only 1 to the left. And here is a vertical translation 2 up. Okay? And the reason we wrote that special note is because when you're in the middle of a question and you're just going from left to right, can you see yourself thinking, oh, I'll go 3 to the left because I see a plus 3. It's so easy to miss that little step where you have to write it in factored form. So now we're going to use the graph of the square root of x. This would be a graph they don't need to give you because you know it already. 0, 0 is a key point on that graph. And from your graph before, you know 1, 1, 4, 2. You know a couple of points on that graph. So you could do these green transformations to those points. Now for sure, on a square root graph, you would always choose 0, 0 as 1 point. But for the second point, why might I not want to choose 1, 1 or 4, 2? They're not, if you look at what we're all doing, right? Look at all the math that we're going to do. This one in particular, we're going to get fractions, okay? And it's not bad to get fractions. So you're right, they're not divisible by 3. I might go and choose, would you agree that 9, 3 is also on your square root graph? Square root of 9 is 3. So I'm going to choose 9, 3 as my second point, just so that I can avoid fractions. Not that they're bad, but they're just going to be more tedious and a little bit extra work, and you're not going to be able to go as fast. So once I've chosen those 2 points, I can say what's going to happen. Always do our stretches and compressions first, and then our translations after. So labeling above our stretches and compressions, we've got y by negative 1 and x by 1/3. And our translations, we got 1 to the left and 2 up. So what's going to happen to 0, 0? It's going to stay 0, 0. But 9, 3 will now be 3, negative 3. 1 to the left, negative 1 and 2. 2 up, plus 2, minus 1. If you can, I would recommend drawing your new graph or your new equation on a new graph So I now have the point -1, comma 2. I'm going to label that. And 2, comma -1. And I have 2 points. And I know that this one was 0, 0 to begin with. So this point is going to be my starting point. Now, how do I draw the shape? That's the next important thing. Because I could draw a straight line, but I would lose marks for that because it's not a straight line. So I could draw a square root graph curved this way, or I could draw a square root graph curved this way. Which is the one that's going to be the correct one? That one there? So the way to think about it is go through what you wrote down. If I do a vertical reflection, can you see that that would make it that shape? And so if that's going to be the shape when I go to my actual graph here, I know that it has to look like this. Okay? On a final exam, they would only look at your graph, and this question would be worth 4 marks. It's a lot of marks. They give 1 mark for the reflection, 1 mark for the compression, 1 mark for the left, 1 mark for showing that it went 2 up. And so if you can see that in your graph, and so your points labeled are very important, then you're going to get full marks. Okay? One little mistake can cause a lot of problems. And so if you drew the shape wrong, they'd probably take away the mark for that vertical reflection. Okay, the question said, what are the domain and range of just the new function? So since we have the graph, the domain are our x values. My smallest x value is -1, so I can say x is bigger than or equal to -1. For my range, I have no smallest value, but I have a biggest value, so I can say my y values are less than or equal to 2. Okay? The other thing I want to point out with this equation is they could have just said graph this equation. And then you would have to recognize that's related to my square root graph. Come up with the red graph on your own and the points on your own, and then do the transformations. Okay? So the textbook gave you that extra graph, but this would be one on the exam. They would say, no, you can do this directly. Yes, question? Yeah. That's nice. That's more proper. In fact, even this is a little bit shorthand for set notation. Okay? But they'll accept y is less than or equal to 2. If you have less than or equal to a number, they would assume all real numbers. So if that real numbers is not there, it's assumed. Proper set notation, they very rarely get students to write it anymore. But if I want to write proper set notation for this, I would start with a fancy squiggle bracket and then say, I'm looking at my y values, draw a long straight line. This long straight line stands for such that, obviously. It's probably what you think every time you see a long straight line. All y values such that y is less than or equal to 2, where y belongs to the real numbers, end with a fancy squiggle bracket. That is complete proper set notation. But it takes so long that people start to do shorter forms of it. In fact, when I was in school, we always had to write out all the long form, so I only used interval notation because I didn't want to write that much stuff. I mean, it's not that long. It's not like you're having to write an essay or anything. But you're going to find out mathematicians are inherently lazy, and so they're trying to find shorter and shorter ways to write things. Like, oh, this is perfect for such that. Okay? You want to see some other ones? Okay? Does anybody know what this says? That says for all. That's math. Instead of having to write for all x, they write an a upside down. Or this is another, oh, I really like this one. If. That stands for if and only if. Not just if. If and only if, then we'll add an extra f to say this can only happen in this situation. So there's some new math words for you, such that for all, if and only if, right? You've probably seen the belongs to or is an element of, right? The XER. X is an element of the reals, right? But we don't want to write all that. We'll make up a new letter. Okay, questions for practice on this one are 8 and 10.